Hi everyone, I hope you are doing good. So today we will take a new DSA question here. And the question is we have to find basically the maximum trains for which stoppage can be provided. So here the question says you are given n number of platforms and two main running railway tracks for both the directions, right? What does it mean? For example, we will have basically n number of platforms, right? So for example, this is platform P1, correct, and this is platform P2, right, and for example this is platform P3, and we have in between some main tracks. So this is for this side and this is for this side. So two main tracks we have here, that is what it is mentioned. So here two main tracks for both directions and n number of platforms which we have. Trains that need to stop at your station must occupy one platform for their stoppage, and the train which need not stop at your station will run away through either of the main track without stopping, right? So now each train has three values: first arrival time, right, arrival time it will have, the second departure time, and the third is required platform number on which platform they need to stop. So these three data which we will get with each train data, we are given m such trains, right? Number of trains would be m, correct, and you have to tell the maximum number of trains for which you can provide stoppage at your station. So this is our station, and here we have to find, right, n number of platforms we have and m number of trains data we will have. So we have to tell how many trains can be stopped at our platform, right, at this station. That is what we have to calculate. Let's understand this with the example. And here you have to keep in mind, as you know, right, train timings goes in 24 hours format, right, from 00 to 2400, correct. So that is what we have to keep in mind. So let's take this example and understand this one. So here it is saying the example is n is 3, means we will have three platforms. M is 6, it means 6 train data we will get, right? And as mentioned in the question, it is saying this is arrival time, this is a departure time, and this is platform numbers, right? So for example here 10:00 to 10:30, right? So this train will come at the platform number 1, right? So it will come here and it will stay here from 10:00 to 10:30, correct. So that is what. Now the second train will come at 10:10, right? And then it will stay, it will stay from 10:30. Now on first platform we already have one train that is there from 10 to 10:30, correct. So we cannot stop this train here, correct. As you know, at one platform at a time only single train can be stopped, right, else the other train we have to basically ask them to go up using the main tracks. And the third train, it is saying 10, the arrival time is 10, 10:20 is the departure time, and platform number is 2. So platform number is 2 is empty, correct. So here we can stop this train 10 to 10:20. So this is 10:00 to 10:20, right. This train can be stopped here. Now here this one, the fourth train, it will come at 10:30. So here on and it will come on same platform number 2. So here you see that the arrival time of this is 10:30, and the departure time of the previous train on the same platform, that is platform number 2, is 10:20. It means this fourth number train can come after this train, right. It is coming after this one, after departing of this one, the third train, right. So it can be stopped here, right. So which train? This is 10:30 to 12:30, correct. So now coming to 15, it is coming on the platform number 3, and it is coming on 12 o'clock, and it will stay by 12:30, right. So that is 12 to 12:30, correct. And now the last train is 9 o'clock, and it is staying for 10:05, right. So it is coming here from 9 to 10:05, right. And now consider here, see here, if you serve this train, then you cannot serve this one, Else if you serve this train, then you cannot serve this one. Why? Because see, here the arrival time, departure time is 10:05, and here the arrival time is 10, right? It means if this train, sixth train will come first, right, 9 o'clock, and it will stay by 10:05. But now the other train come on 10 o'clock, right? So now we have to pass this train directly, right? We cannot serve this one. And then after this, the second train, right? So this can be served now, because the first train will leave 10:05, and this train will leave come at 10:10, right, after 5 minutes of leaving the first train. So now this train can be served. So now this 10:10, this one, and this is fine, right, 10:30. So this train now can be served, but not the first one. So this is the question. I hope you understood this one, right? So let me clear this one, and then we have to think about the solution, because see here, if we go by from taking the first, second, third, then that would not give the maximum stoppage, correct? As you saw, this is the last entry, right, which is saying the train is coming first and then leaving in 10:05, correct? And if we are serving this one, then we cannot serve the first one, correct? So likewise, we have to consider all the scenarios where data could be randomized, right? The train data could be randomized here. So we have to find the optimal solutions where we can get the maximum stoppage, we can serve the maximum number of trains at our station. That is what we have to find. So think about the solution, think about the algorithms which can be applied here to solve this question, right? And yeah, if you get any different algorithm solution, then whatever we will discuss, then please comment below the video, and also let us know about whatever you are thinking, right? So what I'm thinking here is, what can we do here? So first, what I will do, I will sort on the basis of the departure time. Why departure time? Because departure time is the time where one train left that particular platform, right? So once the train is departed from the particular platform, then that platform will be available for the next train to serve. Correct? So what my algorithm would be, first what I will do, I will sort, right, the data on the basis of departure time, correct? The second step, what I will do, once this data is sorted, right, once this data is sorted, so for example, after sorting the data, what will happen here? So the departure time is this one, the first, right? So here, and yeah, before this also, what I will do, I will basically include this data also, the train numbers also with the this data. So what I will do, if I sort this one, then let me write here. So this 9 to 10:05, correct? Platform number is 1, and this is train number 1, sorry, 6, correct? And then the other train would be 10:05, after 10:05 this is 10:20, correct? So I'm sorting it on the basis of departure time. So this would be 10 to 10:20, and here platform number 2, and this is 10:20, this is third number train, correct? And then again, so this is done, right, this is done. Now 10:30, so this is 10:30, right? And here also, if the departure time is same, then we will sort it on the basis of the train number, right? So here this is 10 o'clock to 10:30, right? Platform number is 1, and the train number is 1, and the other is 10:10 to 10:30, platform number is 1, train number is 2, right? Then here departure time is same, so train 4 will come first, so this would be 10:30 to 12:30, platform number is 2, and the train number is 4, right? And the other one is 12 to 12:30, platform number is 3, train number is 5, correct? So I hope you got it. So this is just, I have sorted this train data on the basis of the departure time and the train number. If departure time is same, then I am sorting on the basis of the train number, correct? So these are the platform number, right, on which we have to stop these trains, correct. So now sorting is done. So now the second what I will do, I will basically traverse through this complete data, right. So I will take here basically for loop, right, and in for loop for all trains, correct. And here what I will do, in this I will check if the, so what I will do, I will basically maintain a platform array also on, and in that platform array we will store the departure time, right. So I, what I will do, so if platform, right, platform of I, right, particular platform is having the less, so what it will be there in the platform array, it will have the departure time, right. So if it is having less than equals to the uh, for example train's departure time, right. So I'm here writing td only, correct. So let me clear this one first. So here what I will do, so this is train departure time. If the particular train departure time is greater than, sorry, here train arrival time, because right, so on particular platform train is already there, right. So now with train data we have the platform also. So on that particular platform, so for example here, right, so first train is coming. So now on the first platform, is there any train, right. So this train is coming, so the platform's data, the time should be less than to the arrival time of this train, right. So either the train should have left before the arrival time, or it should be -1. -1 means the empty platform, correct. So if that is the case, in that case we can accommodate the train on that particular platform. That is what we can do here. So if this is the condition is true, platform of I is less than equals to the time of arrival of that particular train, right. In that case uh, what we can do, we can basically update the time here, right. So here platform of I equals to the time, right, train time of departure, right, because we have to maintain the departure would be 0 1, right, one index here. So that is what we can do. Now each time we will update here, right, and here also we can count plus plus we can do. So here with this count help, we can say this many trains we can store, we can accommodate on the given n number of platforms. So this is my algorithm, this is what I am thinking. Now let me implement this in the C++, and then we will run the use cases also, correct. So let me clear this out here. So see, so that was my solution, and here I have implemented this into the C++ code. So you can see here what I am doing. First I am inserting the train number to the data, because currently we have these informations only: arrival time, departure time, and the platform number. So what I will do, I will push back the numbers here, and here then our data would be this complete data is there then, right. This is the last index. So basically this would be train number, right, here 1 2 3 4 5 6 like this, correct. And the index would be, this is 0, and this is 1, this is 2, this is 3, that is what, right. So now after this why I am pushing this train number here into the data, because I am basically sorting the this train data on the basis of the departure time. But in case if the departure time is same, in that case see here I have implemented the this compare function. T1 of 1 means the departure time, right, equals to T2 of departure time. If both the departure times are same, in that case just consider the third index is train number, right. So that is why I have inserted this train number here, correct. I hope you got it. So now after this I am sorting this here, I am using this sort, so it will take basically order of nlogn time, correct. It is quick sort, and here I am giving the comparison function, correct. And this, after this I am having the one platform array here. This is integer, a vector, right. Here n plus 1 I am taking. Why I am taking n plus 1 here? Because you can take n array size, basically n size array, or you can take n plus 1. Here I am taking n plus 1 because, so for example we have the vector of 1 2 3, right, 0 1 2 3, correct. So I am not basically using this 0th index, right? Why? Because it is easy to understand. Index 1 it means platform number 1 data, index 2 means it is platform number 2 data, index 3 it will store the platform number 3 data, 3, right? Whatever the train is there, that's departure time it will store here. That is why I am taking here one extra space, right, for the platform, correct? I am not using the zeroth index. You can basically quickly you can slightly modify this code and use the n size only, so right, so in that case this array is also sufficient, 0 1 2 also fine, correct? So I hope you got this point here. And then after this what I am doing, I have taken this integer variable to count the number of trains can be stopped, right, or can be served on this station, correct? As I have said, then I'm looping through the all the trains here, right? M number of trains we have, and here I am checking platform number, then train of I comma 2, right? Train of I, particular trains data, and second index, right? 0 1 2 index, this is 0 1 2, right? And here we have train number, correct? So this is third index. So let me write here. So here we have train number, correct? So this is third index, right? This is 2, this is 0 1, and this is 0. So this is train data. So now the second index will be the departure time, right? Sorry, the platform. So here we will get the platform, and in platform array we will check, see here I have inserted -1 for all, correct? So now for example this one, platform number 1 initially will have the -1 value, right? So -1 value will be less than equals to the train I0. I0 means the arrival time of the train I. Train I would be here 0. So train 0's arrival time would be, so after sorting, right? So this would be the first entry, correct? So here arrival time is 9, and this is -1, correct? So then it will go here and then update the data on the platform number 1, right? So here it will update the departure time of this train, correct? 10:05. So next time whenever we will come here and check for the platform 1, then we will compare this data 10:05 with the current train's arrival time, right? So I hope you understood this algorithm, right? This is very simple algorithm. You just have to keep in mind some certain things. You have to take the platforms on particular platform. You have to check for the departure time, and you have to sort this train data on the basis of departure and the train number. So here the time complexity would be here it will take the order of n, right? And here the sorting part would take the n, basically m trains we have, right? Here this is also m, and m log m, correct? And then this is also order of m, right? If we add them, then the total time the maximum or worst case time complexity would be order of m log m, correct? So this is the optimized approach. Thank you for watching the complete video. I hope you understood the algorithm, you understood the approach, code, and yeah, that's all for today. See you next time. Till then, keep learning and keep exploring.